Eli5 How can the sun just continuously burn and burn? People are talking about how big the sun is, and that is the most important part of the answer. I am sure I can and will be easily corrected, but I also think the other part of this is how much more efficient fusion is at producing energy than combustion is. How much mass would you need of fuel to produce in one day the amount of energy the sun produces in a day via fusion? And how much mass of fuel did that take? I will guess it's a significant order of magnitudes difference, but I am an accountant not a physicist. Think of a log that is burning on one end. The fire travels from one end to the other, but the whole thing isn't on fire, just the end, so it takes a long time to burn up. The part of the sun where the fusion reaction happens is like the burning end of the log, it is very small compared to the rest of the sun. The heat and light from the small part where the fusion happens warms up the rest of the sun, just like the fire heats up the rest of the log, but it isn't hot enough to make fusion happen in the rest of the sun. Agree with the other answers, trying to legit make it 5 years old level. The sun is older than the Earth, the time scale is billions not hundred thousands, 4 more zeros, much bigger than all the planets combined. It has only used up about 1/2 of its fuel in almost 5 billion years, way before dinos existed. The amount of sun fuel used since humans have been around is similar to 1 grain of sand worth from the whole beach. It will get bigger than the distance the Earth is far away from it now before it gets smaller. It's turning fuel into more fuel. When it fuses 2 hydrogen atoms into helium, it creates excess energy plus some helium. It does this until the core is mostly helium, at which point it'll fuse helium into carbon oxygen. This happens all the way up the periodic table until the star has to turn silica into iron. That process takes more energy than it produces and so the star dies. Oh, it's also massive. It's just a gigantic ball of fuel. Space is big. Really big. You just won't believe how vastly, hugely, mind-bogglingly big it is. I mean, you may think it's a long way down the road to the chemist, but that's just peanuts to space. The Hitchhiker's Guide to the Galaxy by Douglas Adams. This equally applies to the sun. It will run out of fuel in just about 5 billion years. For reference, that's longer than the time since the first microbes have formed on Earth. The sun has a lot of gas. Like, think of a really big car with a really big gas tank. More gas equals more energy. The sun, unlike a car, creates its own gas while it's running. Think of a car that a whole year driving creates more gas. Eventually the gas it's creating can cause the car to die, but it takes a long time. That's basically it. It's just really big and can create its own energy. Take a teaspoon of gas and light it on fire, time how long it takes. Take a giant swimming pool, fill it with gas, time how long it takes. You'll notice the swimming pool will burn much longer than the teaspoon. You are the teaspoon, and the sun is the pool. By the time the pool is done burning, you are long forgotten. As many previously stated, it's about the mass. More mass or material the longer it burns. Lots of good answers here, but just to add to how mind-boggling outer space is, our sun already has an insane amount of fusion fuel by our standards, but in the grand scheme of things, it's only medium-sized. Look up the giant series of stars to see how insanely large things can get on the cosmic scale, and watch live how your sense of importance in the grand scheme of the cosmos crumbles before your very eyes. The sun is not burning undergoing combustion, it's undergoing nuclear fusion, smashing 2 small atoms together to make 1 bigger atom, and the answer is, the sun is just really freaking huge. Imagine how massive the entire Earth is. Now imagine something 330,000 times more massive than that. That's the sun. The sun just has an incomprehensible amount of fuel that it simply will not run out for billions of years. It's got a lot of fuel for its fusion. And when it fuses things, they can be fuel for further fusion, going from lighter to heavier elements. This is diminishing returns and stops giving more energy than it costs after iron arc. Meaning the star will create less and less energy until it goes supernova, which is a little more complex and to do with gravity. The sun exists in an equilibrium between 2 forces, gravity and nuclear fusion. At its core, elements are compressed so tight together that huge amounts of energy are released. Like atomic bombs going off every second. But since the gravity is so strong, the sun doesn't explode. So you have the fusion at its core pushing out and the gravity pushing in. It is huge. Bigger than your mind can comprehend. The sun is about 330,000 times larger than the Earth is, and nearly 100 of that is fuel it can use to continue to create energy. As that fuel is used, the byproduct is just less efficient fuel. There is so much fuel as it's going to take billions of years before it can sustain fusion. The Sun is absolutely, unbelievably huge. It fuses about 5.4 by 1011 kilograms of hydrogen into helium every second. The Sun's mass, composed mostly of hydrogen, is something like 2 by 1030 kilograms. That's many billion years worth of fuel, even considering that, in reality, the Sun's rate of fusion increases over time. The Sun isn't burning, it's nuclear fusion. Even then it is very very big. It will take longer for it to naturally burn itself out than Earth will exist. It could run out of fuel faster if we become a civilization capable of a Dyson sphere, though the level of technology might also just be impossible. The trick is it can't burn, except by quantum mechanics it can. The fusion of hydrogen to helium-2 is incredibly unlikely, and only by being big it happens often enough to still happen. If it would burn like normal stuff, it'd be gone really fast. Humans have an innate inability to fathom very large or very small numbers. The mass of the Sun is way too big to be comprehended by a human. The large mass means it can burn for a long time. Much longer than tens of thousands of years. The Sun is running out of energy, it's just doing it so slowly that it's not noticeable from our perspective. The human lifespan is nothing compared to the Sun's, it can't. But on a time scale that makes sense to humans, it's an academic issue. It's like a mayfly with a 24-hour lifespan wondering how a fire can keep burning without burning itself out for so long. It will run out of energy eventually. I think it is about 2 to 5 billion years depending on what you count as running out. That is a long time, but it will run out. The Sun is a massive incandescent gas, a gigantic nuclear furnace, where hydrogen is built into helium at a temperature of millions of degrees. It is fusing matter, like making bigger atoms. It is in a way doing the opposite of what you imagine, getting smaller and burning away. It just got a huge amount of fuel, hydrogen gas, enough to last for another 5 billion years. It will run out eventually, though. As others have said, the Sun is unimaginably big. Even more amazing tough, is that it is absolutely tiny compared to other stars. Did you say hundreds and thousands of years? That explains the confusion. Just kidding, it's a valid question. It is running out of energy and it is getting smaller. It's just taking a really long time. Love me a good Sun question just so I can post this.